Hello everyone, in this tutorial I'm going to show you how to use Phoenix FD together with particle flow to create an explosion which mixes different colors of smoke. So here let me show you the final result of our simulation. We will use several particle flow sources, each one with its individual color and different shape, different velocity. And we will achieve this result in the end. Alright, so we start off with a sphere. This sphere will be the emitter for our main explosion. I create a particle flow source, and by default the particle flow source emits particles along its icon. So I'll remove these and set position and speed by the sphere. Okay, so the sphere starts bursting out particles. I will limit the emission only to just a single frame. So at frame 30 we'll have this expanding sphere of particles. Now you can see that we have this grid-like alignment of the particles. That's because they're spawned at each vertex of the sphere, so I'll just increase the segments so that we don't see this effect. And next I want to get rid of the particles that are in the lower hemisphere, so I will create it to editable poly and just chop off the lower part, leaving only the upper hemisphere. Okay, so particle flow automatically distributes the particles to what's left of the geometry, and so the speed needs to be increased. I will set it to 700, and I will add a lot of variation to get a less uniform distribution of the particles. Okay, so if you want to change the shape of this funnel, you can scale the cap of the sphere vertically and thin it out like this. So I would like it to be in this shape, and also I will add a delete operator right here to clear the particles when they reach age of 8 frames. Okay, so here it is. So this will emit our explosion, and now we are ready to move on to Phoenix. I will just get the particle flow source out of the way, and I will draw the Phoenix simulator around the particles at their very last frame of existence, like this. I will also decrease the resolution to around 1 to 2 million, 1.5 million at the moment. I will jam the grid on the lower side, so I will use lower resolution to be able to simulate and get a preview quickly of what's going on, and I will just change the dynamics to the preferred fire and smoke setup. So I will use the vorticity multiplied by velocity, because it will not tear up the smoke in the slower parts. I'll use the default symmetric conservation, raise the quality to about 20 in order to give a better swirling effect and more realism, and I will change the method of advection to multipass to give more detail and reduce the steps to frame to just 1, because more steps per frame will give us a smoother surface and they are better suited for liquids. Okay, one more thing, I will just check the unit scale right here. I will make it half a meter so that we have a bigger scale and more massive explosion. And I will just save the scene. And in order to connect particle flow and Phoenix, we will create a Phoenix source. Okay, and choose a target, the particle flow source, choose the event that we have just modified, and I will use the inject mode of the source so that each particle will burst out the default temperature and smoke. Okay, so we wait until frame 30, and here it is. Now, that's not pretty great. We need to make some modifications to this. I will go to the particle view and first turn off rendering for the particles, like this. And also I need to exclude from rendering our emitter geometry right here, and then I will also from the Phoenix FD properties of the emitter, I will uncheck solid object. That will make it transparent to the simulation, and it will not interact with the simulator except as a source, as it is used right now. Okay, so if we render it, these are gone, and despite the particles that we saw rendered here, our particle trails are quite thin. So the reason for this is that here in the Phoenix source we have this option, use particle size. By default it's unchecked, and this means that each particle will be just one cell big in the grid, no matter what its size is, because by default particle flow has a size of 10. Now we'll check to use this, and we'll simulate with the real size of the particles. Okay, let's stop it, and I'll set the start frame to 29 so that we can start just before the interesting part. Okay, so right now we have overdone it, and we need to decrease the size of the particles right here. So I will decrease it to 4, and I would also like to be able to see the actual particle geometry. Here from the preview options of Phoenix, I will check to preview only if selected, so when I deselect it I will be able to see the particles. So here they are. This is the size of the particles with size 4, and here you can choose a shape for the particles, but Phoenix ignores the shape actually, and it always uses spheres, so I'll just choose the 20-sided sphere to get a more accurate preview of what Phoenix sees actually. So in this context we don't need rotation, so delete it, and let's see what happens now. With a smaller scale we get much more distinct traces of the particles. Now, in order to get a better view, I will enable the Phoenix GPU preview here. So the Phoenix GPU preview works only when the simulator is selected. So right now we see only the emissive part. To deal with this, we then to be able to see the smoke as well, we need to add some kind of white to the scene. So we will use a standard Omni White from 3ds Max, and here's the standard drill to be able to see the smoke shaded properly. So we will enable shadows, we'll use ray trace shadows in case we're rendering with scanline, and from shadow parameters we'll enable the atmosphere shadows. And one more thing we need to do is to, here from the preview options of Phoenix, the GPU preview, we will tell it to use this white. Okay, and here it is. So we can preview in real time the simulation without the need to render it. We can turn it around and see all aspects of it. So now we are ready to improve the look of our explosion. Okay, so next thing I want to do is to add velocity to our Phoenix source, and when the particles are emitting velocity, actually this means that they will try to drag the content of the simulator from their position, and this way the content will start to raise up following the particles. We will need to just push the top of the simulator a bit. Alright, so here it is. Now we can also try and exaggerate the effect a bit more, so I will set the velocity to 10, and this means that this way each particle will apply 10 times more velocity than its actual velocity is. So here it is. This way we will push all the smoke and the fire upwards, and this way after the particles go off we will get a nice mushroom cloud. Just something that I will do before we continue. Here from the rendering options, the coarse and transparency, and I'll go to smoke density and increase it to 0.5 like this, so that we can get more dense and thicker smoke to make it look more epic. Alright, so by pushing the velocity up, we have lost the distinct particle projectiles. So I want to make them more realistic and have each of the particle projectiles have a sharp edge. So a way to do this is to we need to tweak several parameters, and first I will animate the size of the particles towards 0. So I will add a scale operator right here, because the shape, the size of the particles, they cannot be animated, so we need to scale them. And I will use the particle age time base, and also use the absolute type of scale. So particle age time base means that the 0 frame right here in the timeline corresponds to the birth of the particle. So if we decide to change the particle birth here, the scale animation will not be affected. Okay, so we start by 100%, and by age 8, where the particle dies, we will animate it to 0. Alright, so here in the preview we can see that now the particles are getting smaller until they disappear. I will also add 70% size variation, and we see that something strange is going on here, and the slower particles are also the smallest. So the reason for this is because right here the random seed of the scale and the speed are the same. So if we change the seed of the scale, we see that the relation is gone, and we have now randomly bigger and smaller particles. Okay, and let's run the simulation. Oh no, we need to change a couple more stuff. So right here the Phoenix source also has an option to choose between particle age or absolute time base. So again, we will use the default particle age, and again by frame 8 we will animate the discharge to 0 and the velocity to 0. The discharge actually it is the speed, the rate at which the smoke, the temperature, the velocity, and all the other parameters of the source are applied. So if you need to animate the rate at which these inject or brush into the simulator, you can control them at once with the discharge altogether. Okay, so here we got the desired effect, and we have these sharp particle projectiles right now. So the next thing I want to do is to increase the temperature. I will stop the simulation and increase the temperature of the source to 4000 degrees in order to get a flash at the beginning, a bright flash, but I need it to cool off faster than it cools off right now, so I will increase the cooling right here from the dynamics parameters. And also this way, when the fluid cools down, it will ascend more slowly, so this way it will not escape out of the box too quickly. I will also add little noise right here. It's always good to have some noise, and I will increase the resolution to about 7 million, and I will run it again. Okay, so now we can see that with the increased resolution we got a much better detail and that's pretty much the shape that I wanted for our main explosion. So let's move to the colors. I will add 2 more explosions to the sides of this blast. I will just here I will change the level of detail to reduce the resolution a bit and relieve the user interface and make it more responsive. Okay, so as I said, I will add 2 more explosions right here to the sides of this one, and both of them will have this sharp conical shape, and I will give them brown color to create the effect of the explosion lifting ground and dirt into the air. So let's start off by creating a cone. Okay. And I will go to the particle flow options, and so just let me make it not renderable and non-solid to Phoenix, and then I will copy this event into a new one and use pretty much the same settings. We will preserve the scale animation and the shape and the deletion by age. I will just make them different colors in the viewport so that we can differentiate between them. Okay, so I will choose the cone as the position source, and the speed will come from I need to set the vertical speed to those particles, so I will create a plane underneath the cone right here, and I will use it to control the direction of the speed. So this way the particles will follow the conical shape, and they will move vertically along the normals of the plane. Okay, so I will just change the speed with a little less variation, and I will add some divergence right here. I will also change the seed to make it more pointy. Okay, I will also decrease the count of the particles, the amount of particles right here. Okay, and so this will be it for this one. I will copy it and paste it again for the right additional explosion, and I will just change again the variation of the speed, and we need to also clone the geometry. Okay, so here it is. I will have to make the planes also not renderable, non-solid to Phoenix. Okay, and okay, not renderable. And then I will assign the copied plane and cone to the particle flow source. Alright, so let's see how it looks like. I'll need to change the seed right here of the speed in order to give a different shape to the right one. Okay, and I will just rotate them a bit to the side so that they are not parallel. I will rotate them together, the cone with the plane underneath. So here's what it will look like. I will also stretch the middle explosion a bit, like this. Okay, and this should work. Alright, so we also need to clone the Phoenix source and give it a bit more different options. Now we won't have temperature because this is just the ground, the dirt, and the dirt that is lifted from underneath, so they won't be hot. They will just emit smoke. They won't emit velocity, but they will emit RGB. So here we will use we will choose a color, like here, this white brown color, and we could make it even more, yes, and what else? I think this is it. So I will clone this for the right one, change the color a bit to something more different, and we will assign them the proper events from particle flow. Okay, so I'll assign this one event 02, and this one I will assign it event 03. Whoops. Okay, like this. And yes, we have to enable the RGB for our base emitter, so I'll say I'll set it to a certain shade of gray, like this. And in order to be able to simulate the colors, we have to go to the output and enable the RGB channel. And now we are ready to start mixing colors. Okay, so here in the preview, in order to see better, I will just choose the end condition and disable the temperature. Okay, so right now we'll see a preview of those cells that have both smoke and RGB in them. And because the colors are multiplied, I will just brighten the darkest part of the smoke and also the whitest, and so here we can see where the brown and where the gray color is. Okay, so while the simulation continues, we will go to the settings of the rendering, and in order for the RGB to render properly, we have to choose it for smoke color right here. Otherwise, it will just use this simple color here. And when I render, we see that we have these two colors right here. So while in the render parameters, I will also enable the emission of light, and I will use the quick grid-based self-shadowing with 10%, the default grid reduction, and also the reduced grid white placing, which will illuminate the areas around the simulator, the geometry around it. So right now, when I render, we have this self-illumination here, which is not so visible right now because the fluid has almost cooled completely off. And I'll just adjust the field of view to give it more of an isometric shape. And I will just wait for the simulation to unfold. Okay, so here it is after a few frames, and we can see that the colors have started mixing up, but I think I need to adjust, just return this, the shape of the middle explosion to more wide, like this. And I will also move the white source more to the side and higher. Okay, and so I will just increase the conservation to a bigger value, like 50, and give it another try. Alright, so here it is, and we can see that the smoke really has formed a mushroom cloud after the here it is, after the particles have gone off. So by increasing the conservation, you will make sure that the mushroom cloud and the smoke in general is more tightly packed and without how to say, without smoke poking out in irregular shapes, and it will just be really give it more tight appearance. So here in the preview, if you disable the smoke, the blending with the smoke, you can see how the RGB was affected by the simulation. Okay, so I will just, for the sake of faster simulation, I will again decrease the conservation, and we will continue with just a couple of supporting features, and we will add a couple more particle sources. So first off, I will create a particle projectile, an explosion of particle projectiles near the ground. So I will create another sphere right here, a more bigger one, and I will give it a more elliptical shape. Then from the particle flow options, I will, oops, I will copy the event for the left ground explosion, and I just forgot to make the ellipsoid non-solid and not renderable. Alright, so I will assign right here the newly created sphere as the position and the speed of these particles. Choose a blue color for them. Okay. I will increase the amount to 300 and decrease the size to 1.2. Okay, so we have many of them, but they will be smaller. And also I will decrease the speed to 400 plus minus 200, and I will remove the divergence so that they will fly off right according to the normals of the ellipsoid that we have created right here. Okay, so we need a Phoenix source, so I will clone this one, move it right here, and I will again enable the temperature, set it to a lower value like 2000, and use the inject mode, and also add some velocity, but not 10, more like 3. Don't forget to key it so that it will go down to 0 at the end. And also I almost forgot to pick the right event, so it will be event 4. Okay, and we are ready to start. Okay, so here it is. I will just increase the size of the particles a bit. And set it to 1.5. Now try again. Alright, and here is the result with the bigger size of the particles. So when you increase the resolution here, this will get better. Right now we have these little puffs of smoke where the particle size changed as they were flying. So the next thing, the next to last thing that we're going to do is now, in order to attach the explosion to the ground and not leave it hanging in the air like it is right now, I will create a plane along the bottom of the simulator, like this. Again, make it non-solid and not renderable, I will raise it a little in the air, like 0.2, 0.3 even, in order to make sure that it is inside the simulator, and I will also display it as a box. Okay, so I will add the Phoenix source that will print inside it some smoke with a neutral temperature of 300, a white color, and it will print it in the shape of a map that we give it. We'll use a gradient map right here, and make it radial. Just change it, and we make sure that the mapping is planar from object XYZ, like this. Okay, so I will animate the discharge, and this smoke on the ground, it will act like sort of the shockwave of the explosion. So by default it will be 0, but at the time of the explosion it will start to print itself into the grid with a discharge of 40%. When we're using brush mode, the discharge is in percent, and at the end of particle emission, at frame 38, it will drop down to 0 again. So let's check it. Alright, so here we can see the beginning of it. Okay. Okay, and so in order to connect the simulator with this under tray that we have put right here, we will add just a final particle flow source that will blast this ground smoke with just with velocity. So we'll use a cylinder right here and place it at the bottom of the grid, like this. I will convert it to editable poly and get rid of the lower and the upper cap. Whoops. Okay. So I will move it into the grid and again make it non-solid, not renderable. I will go to the particle flow source, copy the last event, and so I will create a bit more particles, so let's just assign it first to the cylinder. Okay, so here we see that it emits particles only onto the ground, I will increase right here the divergence, so that it doesn't follow the low poly shape of the cylinder. So here it is. It will emit this blast wave on the ground. I will change first the amount of particles to 1000 to make it more effective. Okay, and I'll decrease the speed a little bit, so that the particles don't exit the grid. Okay, and I will use a smaller size of 1.3. Okay, so we'll just need another Phoenix source for this one. Again, pick the right event, and I will disable the temperature, disable the smoke, no RGB, only velocity. And I will use velocity of 2 in the beginning, because we have a lot of particles, and their amount should compensate for their smaller size and low velocity. And okay, I think we're ready. So let's run it once again. Okay, so here we are, and this was the final particle emitter of the simulation, and the final blast emitter. So we will add just a couple more final touches, and we will be absolutely ready with the simulation. So one thing I will add first will be just an infinite plane that we'll put underneath the simulator, and it will act as a background. So I will just use an infinite number with many zeros here to make it as large as possible. Okay, right here. So this way it will work kind of better with this gradient background. Now having shadows on the ground, and it looks like it really is in contact with the surface. So one more thing you might want to add is a bit of wind. So gotta turn it in the direction of the simulator, and the wind affects Phoenix a lot. So 1 is a big value, and you might want to animate it from the start. Right here, where it will be 0 until .1, and then gradually decrease it until 0, or otherwise it will continuously accelerate the content of the simulator. Okay, so here you can see the particle blast wave on the ground. And also you may want to use gravity, the gravity space warp, in case your particles fly in the air for a longer period of time. But in this case you need to be aware that all space warps are by default included in the interaction list of Phoenix. So the gravity will not only affect the particle flow particles when you add a gravity operator to particle flow, but they will also affect the content of the simulator. So right here in the interaction panel you can see the list of the active space warps. So you need to be aware that in case you're getting some strange behavior out of the simulator, please check this and see if there is some gravity or some wind that you have forgotten, and it might save you a lot of time looking for whatever is causing the problem. And so one more thing before we press the simulation is to enable the adaptive grid by smoke. I'll just lower the threshold a bit and add some adaptation limits to the expansion, so the grid will be able to expand in the direction of the wind and also to expand up as the smoke rises. And that's pretty much it. So I will increase the conservation again, and I will increase the resolution, render, and come back to you. Alright, so here is the final result. I have changed the renderer to V-Ray and added V-Ray dome white just to get some ambient occlusion in the scene alongside with the max omni white. So this gives a pretty good result, and also this one is still just 27 million cells. You could also increase this to maybe 100 million and you'll get even more detail, and you could also choose to increase the conservation if you like, but I think that this one is enough, and it will also double the simulation time. And so that's it, and I would like to thank you for watching and see you next time with the next tutorial.